We have 3 phenomenal stories around IoT, engineering daring do, and Ghanaian girls and tech. So to introduce each of them, I'm going to bring up Karen Wickre.
Well, thank you, everybody. Get more coffee if you need it. I'm Karen Wickre. I run my own consultancy called KVOX Media, which is editorial strategy. And I'm happy to moderate this session, which is an interesting mix of tales that go from the present to the future. And I think you're going to enjoy the stories along the way. Let me introduce first our first speaker. Each one will have about 10 minutes to talk about their tale, what they're doing, and then we can circle back with questions. So Aidan Madigan-Curtis is the head of new products at Samsara Networks, which is a new company in the Internet of Things space. A very fast-moving world. And so her job at Samsara is to bring some of the hardware products to market, overseeing new product engineering, supply chain, operational, commercial management, the plumbing of what makes these things go. So Aidan, let's start with you, talking about the Internet of Things.
I'm going to stand up. I think that's
No, okay.
Great. Hey, everyone. Good morning. My name is Aidan. I'm here to do your plumbing. Just joking. Thank you so much for the kind introduction. I work for a company called Samsara Networks. We do industrial-focused Internet of Things products. And so I'm here today to talk a little bit more about what Internet of Things is really all about, specifically about the concept of sensory technology. This might be a little bit, I think this whole session might be a little bit different from a technological deep dive from maybe some of the other sessions at the summit. So I hope you enjoy yourself. And I don't know if there'll be time at the end for questions, but you can always follow up with me at any point. So I'd like everyone to just take a brief moment. It's been a hectic morning. Breathe in and think about all of the annoying things that happened to you on the way to the summit this morning. Really think about it. Did you have to park your car? Did you have to wake up, make your own toast, get things warmed up? Yes, there are so many things in our day-to-day lives that are deeply annoying. I think one of the wonderful things about technology is that it can solve all sorts of big problems. It also solves all sorts of little problems. And what I love about Internet of Things is the concept of bringing the internet to our day-to-day lives and digital connectivity to our day-to-day lives to help us solve some of those problems. So I feel a little bit like I'm preaching to the choir here. Many people in Silicon Valley are very excited about the theme. But what I really wanted to do today is take the time to get a little bit more specific. I think the Internet of Things, quote unquote, is a bit of a buzzword. And so I wanted to talk briefly about some of the key themes that are enabling this concept, and then to do a small deep dive on sensory technologies, because that is more my specialty. And understanding it better will definitely help you guys get a better understanding of what IoT is really all about. So taking a step back, if you ask kind of what are these key themes that are enabling this Internet of Things, quote unquote, revolution, I would say that there's really 6. There's Moore's Law, which reflects just how quickly and how tinily we can do things on a piece of silicon within a computer. There's sensors and machine-to-machine communication, which I'll talk a lot more about in just a minute. There's this concept of big data, how quickly we can actually process and understand and interpret tons and tons of information, which I think one of my fellow speakers is going to speak more about this morning. There's this notion of AI. How do you give a machine intelligence? And amazing advancements that are happening in that space. There's this notion of having fast and ubiquitous wireless internet. Key advancements in that space are also essential to enabling the Internet of Things and bringing our digital lives to our everyday surroundings. And then finally, actually, it's important not to overlook power. Basically, in order to do anything with a machine, you have to power it somehow. And there have been some really great advancements in power that have enabled Internet of Things as well. But today we're going to talk about, I can't talk about all of that in 10 minutes, so nor am I qualified to talk about most of that. But sensors are something I'm excited to talk to you about. So what you see here is a new, special, colorful type of sensor. I'm just joking. These are jelly beans, in case you didn't notice. What I'd like everyone to do is remember back when they were young and you had a jelly bean counting competition. So the question I'm about to ask you reminds me a little bit of this notion of a jelly bean counting competition. Who can name all the sensors around you? Just shout some out. Sensors that are happening right now in your day-to-day life, not counting the ones that are part of your body. Thermostat, yeah. Fitbit, totally. There's interesting things happening in your Fitbit. What else? Yeah. You know, it should be helpful. I still bump into things anyway. Anyone else? Anything else? One at a time. Microphones, GPS, automatic doors, any number of. There's sensors basically everywhere these days. And it's actually pretty easy to forget about some of these advancements that are helping to pick up information that we and the things that we use are throwing off all the time. So just to name a few, yep, we heard microphones and amplification, GPS, accelerometers like in your Fitbit, magnetic sensors on automatic doors, there's strain gauges like you'd see for bridges, there's thermal and humidity sensors, gyroscopes, chemical sensors, wireless sensors, the list goes on and on. So I guess I kind of wanted to briefly break it down for you. I feel like we're just going to do a small technical deep dive here. I think you'll probably enjoy it. I oftentimes feel like when I go to hear a talk, if I don't walk away really having learned something, I'm sort of like, well, why did I just spend 10 minutes of my life doing that? So let me share a little bit with you about some of what I've learned about sensors. Sensors are transducers. That means that they are a digital piece of equipment that can receive a stimulus and respond with an electrical signal. By stimulus, I mean basically anything that can receive a quantity, condition, or property and convert it to a signal. Sensors are actually fairly simple at a baseline level, and they operate fairly similarly mechanically or electrically. I'll describe what that means a little bit more in detail in a second. But I wanted to take you briefly through some different types of sensors, like the ones that you named this morning. First, thermal and humidity. These types of sensors actually play a huge role increasingly in our lives and are certainly behind a lot of the smart home theories, et cetera. So what thermal and humidity sensors are actually built on from a physics perspective is this notion of a changing capacitance. So essentially, a specific temperature of air will have a certain amount of water content in it. As the temperature rises or falls, that water content is different. And that actually can create a change in the dielectric content of the water. This change is that same stimulus that I just mentioned. And it can throw off a signal that says, okay, now the temperature is 1, 2, 3, or 4 degrees higher based on the water content in the air. That's also why, for the most part, thermal and humidity sensors come packaged together, because they actually work hand in hand to change the capacitance. Infrared sensors. Essentially, these are based on some of the simplest principles we see in the mammal world. You've got bats. So this notion of an infrared light wavelength. The infrared sensor will pick up specifically infrared light wavelength and will sense when it gets bounced back at it. Accelerometers, so someone mentioned the Fitbit. I love accelerometers. I think that they're doing all sorts of fun things in our world today. Essentially, this is also based, remember earlier when I said a lot of them are based on similar key concepts. Accelerometers are also based on a capacitance change. Essentially, they're these tiny little microscopic microstructures that have a natural capacitance between the two fingers. As a piece of equipment moves, or as you move, on a very microscopic level, those tiny little structures come closer together or further apart. And this creates a change in capacitance, which again is a signal that can tell you whether or not you've moved or a vehicle has moved. RF. So if any of you have had that annoying experience when you're walking out of a store, probably everyone, and the door goes off and you didn't do anything. RF is a very popular concept these days in the concepts of asset tracking or things like tags in clothing. Essentially what's actually going on in that tag is it's a tiny, tiny coiled antenna. So you see the thing that's going around in a circle there, that's a piece of copper that's acting as an antenna. And it's actually picking up radio frequency signals that are being given off by those big structures when you walk out of a store. And they will signal whether or not the antenna has been deprogrammed or not. So that was just several examples that give you a little bit of a sense of some of the physics and mechanics underlying the sensors in the world that you live in. I guess the last thing I'll say broadly about sensors is that they don't exist in a vacuum. The last time I gave this talk, someone raised their hand at the end, was like, I thought that there were lots of vacuums with sensors in them. What I mean by that is the sensors don't exist alone. You know, an accelerometer left to its own self basically won't tell you anything. It needs to be plugged into some form of power. It needs to have a mechanical interpreter. So oftentimes this comes in the form of an app processor, a key piece of silicon, a driver that can understand a signal. It needs to be connected. You know, you can have the most intelligent device, but if it isn't generating a signal that can be communicated to something else through connectivity, wireless, Zigbee, otherwise, you can't get any information off of it. So I just wanted to highlight that sensors in and of themselves, there might be really cool advancements, but without advancements, as I mentioned earlier, in the rest of these fields, Internet of Things and sensor technology would be pretty useless. The one deep dive I'll say is on connectivity. I think this is one of the coolest aspects of the space. There are lots of different types of connectivity. I'm sure you've heard of, whether it goes back to old Ethernet, all the way to Wi-Fi and Bluetooth, which were some pretty great advancements in the last decade or so to make wireless connectivity a lot easier and faster. And then with even newer advancements, you might have heard of quote unquote sub 1 gigahertz technology like Zigbee, which enables incredibly long distance, up to, you know, from 200 meters to 2 kilometers signal on a wireless basis. So lots of cool advancements in this space too, bringing to life the world around us. Again, last thing on a detailed level would really be people wonder how much these types of things cost. So, you know, it's a lot of information right here, but essentially, if you were to kind of roll it all up, you know, all of these things are reflected by pieces of silicon for the most part. They cost money. Plus, you have to ask someone to put them all together, which costs a lot of money in the basic equipment and labor to put it all together. So maybe to get the kind of system I put in front of you there, to build a sensor that can actually communicate and interpret, could cost you up to $65 or much, much more, depending on the level of advancement of what you're looking at. So, because I'm almost out of time, I thought we could just do a couple fun examples. Going back to shouting things out, what type of sensors do you think exist in this funky new car from Mercedes, which is one of their futuristic autonomous vehicles? We just named a whole bunch of them, so I think definitely has accelerometers in it. Anything else? How does it see? How does it think? How does it feel? Yeah, thermal sensors. Battery indicator sensors, for sure. So I love the notion of autonomous vehicles. I think the more we start thinking about giving machines the capability to operate and think and do things for themselves, the more it really depends on advancements in sensor technology. So you guys mentioned some of them: altimeters, gyrometers, and tachometers. Radars in the back, whoever mentioned the rear view camera. Cameras and optical sensors, and then radars also just for general sensing. Magnetic sensors to detect, you know, how close or far away other vehicles might be. Basic pressure sensors, which you already have in your vehicles for the most part, tell you about things like tire pressure. Accelerometers, and then I think one of the cooler ones is LiDAR systems, which you know, Google has been a big champion of. Basically, these arrays of 64 or more lasers that will bounce a laser and see a 3D image printed back to it, and can tell a lot about the environment around it based on that. So last example, you hear a lot about smart homes, but I'm wondering if you guys have some thoughts on what types of sensors might be involved in creating a smart home environment. Totally, yeah. Sensors to open the door, so pressure sensors or infrared sensors. Voice sensors, yeah, like different types of voice and acoustic sensors.
RFID sensors for like pantry, refrigerator.
Totally, yeah. Wouldn't it be great to just be able to sort of wave your phone or wave a controller at something and have it open for you? Photo sensors, yeah. Great, this is great. You guys are awesome. You could give the talk. So a lot of these have been mentioned. So optical infrared to sense movement. These can be used in security systems as well as to tell where you or your family members are. Touch sensors. I love the notion of being able to walk around in my house and just touch things, either gesture at them, gesture sensors, which is a different type of thing through radar, or just touch a screen, touch my countertop, and have it actually interact with me and know what I want. Temperature and humidity sensors, which I went over in detail just a couple minutes ago. Machine to machine, so M2M. This notion of I should be able to give a command to things in my house, but they should also be able to speak to each other. So if my pressure sensors are telling that I'm walking from one room into the other, they should notify, they should know my general pathways and my patterns, and they should notify the machines ahead of what I'm probably about to do. Voltage sensors to generate a sense of what's going on with your electricity consumption. Obviously, you have a house that's this wired. You probably want to understand what electricity is going on. Chemical sensors to keep you and your family safe, and acoustic sensors, which someone mentioned earlier. Be able to speak at your house and have it either respond or at least interpret you. So there's many, many, many applications. These were just to name a few. My talk was called The Future Sensory Technologies, so I think you now have a bit better of an understanding of the mechanics behind some of the types of sensors that exist in the world today, and some thoughts and ideas and imaginations around what could come tomorrow. So thank you very much.
Thank you, Aidan. Why don't we have all three speakers, and then we'll come back to questions for any or all. So next is Akhil Gupta, who's the VP of Infrastructure at Dropbox. I think about a year ago, he was promoted to VP of Infrastructure and joined the executive team, but he's been at Dropbox nearly 4 years, working to scale its infrastructure as the user base at Dropbox has grown 8-fold over the years. So he oversees physical and technical infrastructure for the company and operations and security for it's probably a bigger number now, 1.2 billion files saved to Dropbox every day. So Akhil, please talk to us about the Magic Pocket.
Thanks, Karen, for the kind introduction. First of all, thank you for coming. I'm really excited to be part of this summit, and it's been a fun couple of days. What I wanted to talk about is something Dropbox has done in the last couple of years, which is an extremely rare engineering feat, which we are very proud of. How many of you have heard of Dropbox or used Dropbox? All right. So I'll not spend too much time talking about what we do, but just to set the context, I would like to start with what Dropbox is. We are one of the largest cloud collaboration platforms with more than 500 million users storing more than 500 petabytes of data. Just to give a sense of how big 500 petabytes is, another way of thinking is it's 500 million gigabytes of data. And these users are syncing, as Karen mentioned, more than 1 billion files per day. So the scale is huge. Very few companies operate at this scale. But as the world is going more mobile, as Adrian said, that there's a lot of sensor data coming in, we are seeing an explosion of data and the demand for people to be able to access it anywhere and everywhere. And this is what Dropbox enables. Now, in order to support this scale, Dropbox was an early adopter of what is now called a hybrid architecture. This is a term which is way more common now as cloud has become more omnipotent and is being used more commonly. But Dropbox started using it about 7 years back, where we had a big part of our infrastructure in-house, in our own data centers, but we're also using public cloud services for storage. This allowed us to scale very rapidly as our product grew, as our users base grew, without actually paying a huge upfront cost in infrastructure. Around 2013, as we saw clear signs of our adoption, our product, our users growing, we decided to start investing in our own in-house storage. Now, there was a very good session just a while back about how to take risk and embrace failures and risk. I think this was our moment. Building a storage at that scale was something which we knew was going to be challenging. We knew had a lot of risk. And we wanted to make sure that we take the bold steps necessary to innovate within the company. And we decided in 2013 that this is what we want to do. Of course, when we started discussing what we need to do, we named the project Magic Pocket. It's an inside joke where we see Dropbox as this magic pocket where all of your data exists and you're able to access it wherever and whenever you want it. And we wanted to call the system Magic Pocket Tube. And at a very fundamental level, it was an immutable content addressable block storage system. What does that mean? Number one thing, it's a block storage system, which means that we are effectively take all your files, break them into 4 megabyte chunks of blocks, and just put them in the storage system. It is content addressable, which means every block is addressable by a SHA-256 hash of the block, which means that every block has a unique key that can be used to access it. And it is immutable. So this property where we don't support overwriting blocks is an extremely interesting property which allows us to make some trade-offs on the technical front and optimize our infrastructure for our unique workload. So when we start thinking about what we need to do in Magic Pocket, how do we go about taking this huge risk and validating that we can do it? We broke the project into 3 different phases. The first one was building, the second one was validating, and the third one was actually migrating our huge amount of data that we had on a public cloud service into the in-house. Let's start with the first phase, which is the building. The challenges here was that there was no open source or off-the-shelf system that we knew which would work at our scale. Remember, we're talking about hundreds of petabytes of data. The growth we were seeing was huge. We see more than a petabyte of data being added every single day. So there was nothing out there that gave us the confidence that we can actually use it and make sure it works. We had 0 tolerance for data corruption. At Dropbox, we take the trust every user puts on us very, very seriously. We want to make sure that whenever a user puts something in Dropbox, it remains there forever and is not corrupted. So the system had to be extremely resilient to all kinds of random failures. For folks who have worked on infrastructure, you see these weird memory corruptions, bit flips happening on networks, and we had to make sure that everything we build everything in a way which avoids those kind of issues. Lastly, we had an extremely high bar around durability, which means we don't lose your data, as well as availability. The whole thesis, the foundation of what Dropbox runs on and is very popular is that we make sure that you don't ever lose your data and it's available whenever you want it. And this system had to meet those expectations. So like any other project, the build phase started with a couple of engineers. The team was about 3 people and a whiteboard. I'm pretty sure all of us have done projects where we just go into a room, start jamming on ideas. And this team, a very small team, started figuring out how do we design a system that meets the challenges which I just told. And one thing which was very clear from experience of running large infrastructure in other companies was we had to make sure the design and the system is simple. If there is one thing which I would like anyone in this group to take away when they're working on large infrastructure is you can never, ever overestimate the value of simplicity. Whenever you're building large systems, when you're building large infrastructure, the simpler you make them, the easier they're actually to understand, the easier to operate. And this was something which we embraced from the get-go. And after a few months of iterations, coding, prototyping, building, we ended up with some design, something like this. A lot of blocks. I'm not going to go into details of this. We actually have published extremely detailed technical blogs at our website. I would encourage anyone who's interested to just search for Dropbox Tech Blog, and you will see very detailed in architecture and the design choices we have made. But one thing again, going back to the simplicity was, given the complexity and the scale at which it runs, the system is actually very simple and easy to explain to anyone who wants to do it. So the building, as it turns out, was hard. We had to innovate a lot on the technical front to be able to scale a system to exabytes of data. But it was only one piece of the puzzle. The second phase, which, if you can believe it, took longer than actually building it, was what we call the validating phase. As I mentioned, we deeply care about the trust users put on us when they store their most important documents, their most important memories at Dropbox. And we really wanted to make sure that before we start using this system to store user data, we validate everything about the system. So when you think of a storage system, what do we want the system to do? Number one rule, don't lose data. That's one thing which we wanted to validate and make sure that we think of all possible scenarios. And we're talking about tens of thousands of machines running in multiple geographical regions, a network which is extremely complex, and we had to figure out how to think about validating that the system is ready for launch. The way we did that is to break down the validation phase into 4 different work streams. Number 1, isolation. Number 2, protection. Number 3, verification and automation. So what is isolation? Again, for folks who have built large infrastructure, it may not be a surprise, but along with simplicity, one thing which you have to enforce is isolation to prevent failures on a small part of a component. Could be a bug, could be a hardware failure, could be a network failure, not to cascade and bring down the entire system. So not only did we have to physically isolate your copies of data so that if the machine goes down, and they do go down all the time at our scale, we don't lose the data, but also work on how do we isolate operations. How do we make sure that when you push new code, which may have a bug, doesn't go out to the entire system? How do we canary it? How do we make sure when our SREs are managing the system and running in production, they're doing it in a lockstep that any human error is limited to one part of the system where it is easy to recover from? Which goes to the second part of the validation phase, which is protection. What protections does the system have which prevent humans from making mistakes? As it turns out, one of the biggest reasons for an infrastructure failing is typically human. We make mistakes, we run commands the wrong way, we don't follow the checklist of things we're supposed to follow. So a huge amount of investment was made, and more code was written in this part of the bucket than the actual system to prevent the system from errors being done by humans. How do we make sure that no one is capable of doing this proverbial RM minus RF star on 500 petabytes of data? How do we make sure no one is able to run a global command which can destroy the data in a very permanent way? How do we test it? Remember, this is not a static system. Our developers are constantly working on improving the performance, scalability, building new features. How do we build a robust testing mechanism to be able to protect the system from the bugs that we may introduce? In spite of all this, as things happen, things will go wrong. We may introduce bugs which we don't know about. And that is where the third work stream was very important, which is verification. How do we detect something is going wrong? So we have done a lot on isolation, we have done a lot on protection, but we also wanted to invest in spite of our efforts, how do we make sure that we are detecting any data loss, any inconsistency in the data model, and do it in an automatic manner. So we have a huge system which effectively is the proverbial watching the watchman, which keeps going and saying, hey, Magic Pocket, you think you have this data, tell me, verify that you have this data. Give me this data back, and I'll make sure it's not corrupted. And that machinery has been extremely valuable for us to have the confidence that if there's a bug that we missed in spite of all our testing, in spite of all our validation, we can still detect it and recover it quickly. The last, but very important, goes back to what I just said, which is the biggest common reason for systems to fail is human, is to how do we automate as much as possible the operations, the way to recover from systems, and have it done by machines. Humans are fallible. We make mistakes, but if you write programs which are well-tested, which have a very clear and simplest design, can we push all the operations like replacing machines? Can we push operations like replacing hard drives when they go bad be automatically done, as opposed to relying on humans to do it? And these 4 were extremely valuable for us to get the confidence, but we were still left with what I call the curse of unknown unknowns. When you're building infrastructure, you always have to spend a lot of time figuring out various failure domains, what may happen, what are the probabilities of things X, Y, and Z happening, which may result in some kind of issue. But there is no way you will ever be able to convince yourself that you've thought of every possible scenario. And that is the unknown unknown. And that, at our scale, becomes a question of when, not if. So anything and everything that you can imagine and you cannot imagine will happen, and we have to make sure we are very, very confident that the chance of that happening is very low. So how do we solve that problem? So we have done all this stuff. We have built the system. We had built a huge amount of machinery around isolation, protection, validation, as well as automation. And the question came to the team, OK, do we think we are ready? And we said, no, we still need to figure out if there is some bug lurking around which may crop up tomorrow. So what the team did was something which I was very proud of, where we launched the system in what we called a dark mode. So a big part of our user base was running on Magic Pocket, but we were also keeping copies of the data and the blocks on our existing public cloud service, and had the capability of failing over to the public cloud service if we detect any issue. And the contract and the team actually had this manifesto written, which Drew and Arasha, founders, signed, was we have to have this system run like a true production system for 3 months without a single incident. And every time an incident happens, we reset the clock. So there was a huge clock in a TV which we put up around where the team was sitting, which had a countdown. And every day, people would come and see, OK, the system is still running. This is the classical 10 days since the last accident mock-up. I think this is the only probably JavaScript my team wrote. Everything else was done in Go and Rust. We did have one incident where we discovered a very rare bug. While it did not lose any data, the team was disciplined enough to be able to say, hey, while this did actually not result in an issue, we are going to reset the clock. And the clock was reset after 30 days. But then we waited for 90 days. And finally, in February 2015, we were able to say, hey, we have done everything possible. We have spent 3 months watching the system. Everything looks good. Let's call it done. This was a huge moment for us. This was the official launch of a Magic Pocket, where we were able to say, we are now capable of storing users' data without a backup or without using a third-party public cloud service. But this was just the start. As I mentioned, building, validation looks good. Now comes the more interesting part. By this time, we had more than 500 petabytes of data. The number may seem small, but if you start doing the math, it's a lot of hard drives, a lot of data to push through the wire. And we wanted to see how we can now, given the confidence that we had built on a system, how can we migrate as much data from our public cloud service into our in-house infrastructure. This was the start of what a project we called Base Jump, because this was a point of no return. The company, the infrastructure team, was literally jumping off a cliff and saying, at this point, it's a race. We have to keep migrating data as quickly as possible and make sure that we hit the certain deadlines we had set for ourselves to make sure the migration is quick and painless. Challenges in this. This itself was also not very easy. We had to scale our system. And remember, this is a system which we have built, so everything from network, servers, from a couple of 100 petabytes to exabytes of raw storage. Lots and lots of machines, lots and lots of hard drives, and all of that had to be done in 6 months, where we had to move more than 500 petabytes of data. This required flawless execution across multiple teams. Our supply chain team had to work with our hardware vendors to make sure the servers land on time. Our network team and data center team had to make sure the network is plugged in, the machines, when they land, they're installed. Our SRE team had to make sure they are put in production. And then our software team had to make sure they keep fixing bottlenecks as they come and react to them. And most importantly, we had to handle the unexpected. As I mentioned, one of the biggest challenges running infrastructure is not knowing what's going to happen. And we had quite a few stories about them. One interesting one which I like to tell is, if you can believe it, because of redundancy, we take supply chain very carefully, and we make sure the machines we are getting are sent through separate trucks. We had 2 trucks, 2 deliveries of servers coming at the same time from 2 different regions, and both of them had an accident. Luckily, no one was hurt, but it did have an impact that suddenly we were now behind on our server delivery. And you would imagine, what's the odds of 2 different trucks, completely different regions, coming all to California and having an accident on the same day? But it happened, and we had to react. We had to scramble. We had to figure out what's our plan B, what's our plan C. Similarly, there were a lot of network outages. Sometimes our pipes would get broken. Sometimes internet would get broken. And we had to figure out how do we migrate this data without disrupting our schedule. And the good news is, after a lot of hard work, a lot of work by our data center and network team, we were able to successfully migrate all of this data actually ahead of schedule. We were able to move majority of the data by October, and we recently started talking about it publicly. And when I look back on things which made this huge technical accomplishment successful, it starts with what I think is a very core important, which is people. And building a right team is ingredient for every project, every company, and this is what I think we got right. Then we were able to align the entire cross-functional team to a single goal. We focused on communication to make sure alignment exists. So whenever something that did not go as planned, we were able to react quickly. And we took a very iterative approach. As I mentioned, we broke the projects into 3 phases. Each phase actually had a lot of checkpoints and milestones, and we kept adjusting. Anytime you build a large project, nothing will ever go according to the plan. And the success really depends on your ability to react to it and replan and execute again until the next thing breaks. So that's all I have for this. Hopefully you guys enjoy your summit, and thank you for having me.
All right, thank you, Akhil. Next is Rasheeda Yehuza. She's the co-founder of Tech Needs Girls Ghana. I discovered also that she's a busy person. In 2013, she founded Samsara Tech to use technology to solve problems and challenges in local communities around Ghana. And then on the side, she founded Tech Needs Girls Ghana, which is an annual interactive workshop for girls to learn hands-on development for mobile and web applications, interact with software that teaches them more about STEM, which we're all for, obviously, and the girls can meet female technologists to help mentor them. She's also involved in general youth development work in Ghana, and is an organizer and member of the Ghana Think Foundation, an NGO. I discovered that in reading about her, 2 things. She received a Future Awards Africa in 2015 for her work with both Samsara and Tech Needs Girls. And you were introduced to computers at age 8, which should be an inspiration and a message for all to come. Anyway, please welcome Rasheeda now to talk.
Thank you. Hi, everyone. My name is Rasheeda, and I'm a software engineer from Ghana. I'm really excited to be here today and to share with you my story, that's my journey in STEM, and how I'm inspired to empower young girls in Ghana in STEM. So I'm from Ghana, and Ghana is an amazing country in West Africa. And we have so many resources, such as oil. But the most important resources we have in Ghana is our youth. And as a result, I'm so passionate and inspired to enable the youth acquire skills in tech and in leadership in order to use it as a tool to develop our country. So I was introduced to computers at the age of 8. And the first time I saw a computer, I was so dazzled by the fact that you could send instructions to a machine via a mouse and a keyboard. And in that moment, I knew I wanted to do something in IT. But it wasn't really a choice because growing up, I had to become a doctor. And so when I told my family that I wanted to do something in IT, they said, no, you can't. I mean, there's absolutely nothing you can do in IT. At that time, we didn't know anything about the STEM industry, computer science, and what you could actually do as a computer scientist. And so my entire family wanted me to be a doctor. In fact, my entire community wanted me to become a doctor. But deep down, I had a drive, which was to build a website. And I needed to figure it out on my own. So in Ghana, after high school, you have about a year to apply to schools and to figure something out for yourself. So when I got to high school, my friends realized that I would get in trouble all the time because I would stay in the computer lab. And so they encouraged me to study computer science in school. But it wasn't really an option, just thinking about it. And I didn't want it to be an issue, studying computer science. So after high school, I decided to go to a computer school to better understand what STEM was all about, what technology was all about. And I remember they taught us stuff like Microsoft Word and Corel Draw and Mavis Beacon to just type in. And that was weird because I remember asking the tutor, how can I build something like Microsoft Office? I don't want to use it. I want to build it. And he would say, no, you can't. And looking back now, I think he probably didn't know himself. But the most interesting thing happened. When it was time for me to apply to the university, I chose to study computer science without telling my family. And I was really scared because they thought I chose medicine. But when the results came through, the day I was supposed to go to school, I told them, oh, by the way, I'm going to study computer science. And everyone was shocked. Everyone was quite unhappy. It was a very difficult time for me. But I knew that was what I wanted to do. I was still very passionate about building a website, and I was hoping that studying computer science would enable me learn how to do that. But when I got to the university, I realized that the average percentage of females studying STEM-related courses, especially in my school, was about 20%. So that included physics, chemistry, biology. And in my class, only 13% were females. And in fact, out of the 13% being females, only about 5% of us wanted to continue and were actually interested in the STEM field. And being as passionate as I was and having faced so many challenges, I knew I had to do something because there were other females like me who were just as interested in STEM. So the question was, how do you empower young girls in Ghana to lead and innovate through technology? The answer at that time was Tech Needs Girls. So I partnered with a friend to start an organization called Tech Needs Girls. And the main idea behind Tech Needs Girls was to provide girls the opportunities I didn't have when I decided to go into the STEM fields, and to introduce them to the concept of STEM. So we organized our first workshop in 2013, and we were able to introduce over 55 girls to the concept of computer science. And for them, in fact, for about 95% of them, it was the first time they heard of computer science. And we got so much support from the Ghanaian community because it was the first event of its kind in the country. One of the amazing stories about Tech Needs Girls is the fact that we were able to impact so many girls that a club called the Achievers Book Club reached out to us. And this was a club founded by a 12-year-old girl in Ghana. And she lived in a community where a lot of the girls dropped out of school by the age of 10. But she knew she wanted to do something in her community. She wanted to empower the girls. So she started a book club for the girls to go to and have resources to enable them to progress in school. So they reached out to us and asked us to partner with them so we could provide a technology resource to the girls. And it was an amazing opportunity because this was what we wanted to do. So with the experiences we had with the Achievers Book Club, we decided that mentoring them was the way to go. Instead of having just annual sessions, we could have frequent sessions, more interactions with the girls, And we could bring in leaders, female leaders, not necessarily in STEM, in their communities who have succeeded in different ways, to act as mentors and to help them in their own aspirations. So one of the things that was very exciting about Techniques Girls in the beginning was how our curriculum was shaped based on our partnership with the Achievers Book Club. So we first of all started with logical reasoning because we noticed some of the girls were not really interested in STEM, but they wanted to learn. They wanted to build confidence. And so we started with our logical reasoning and basically teaching them algorithms and using the things that they are interested in to enable them understand how to reason and how to solve problems. So if a girl loves to dance, we use that particular topic and teach them how to write algorithms with dance or with cooking, whichever hobby that they liked. And then we moved on to HTML and CSS. And that stage was basically to build their confidence. As a software engineer, I remember how I felt when I built my first website. It was amazing just to change the background from red to blue or to use maquette. It was an amazing feeling. So we realized that once they start building their websites and learning HTML and CSS, they became very confident and they were ready to move to the next stage. And the idea of Techniques Girls isn't just to teach computer science, but to build leaders. And so as part of our curriculum, we have leadership. And with leadership, we teach them that whatever skill they acquire in school and at the Techniques Girls sessions, they should think about using that as a tool for development in their communities and for mentoring other girls, and of course, for Ghana and Africa at large. And afterwards, we moved to Scratch game development. Now, this is a different stage, but then it gives us a platform to get the girls thinking about what's at stake and the incredible things they could do with IT. We definitely face a lot of challenges with Techniques Girls, and some of the challenges we faced was the fact that there was low technology literacy and unavailability of resources. It was shocking to find out that for 72% of the girls, the first time they got to interact with the computer was at our sessions. And that was a huge challenge. How do you teach girls how to code? How do you get them involved in STEM when they don't have computers? So that was probably one of the biggest challenges for us. And parents and schools were not fully on board with the program. Just like my family, just like my parents who didn't understand STEM, they didn't want me to get into the field, we faced a lot of issues with parents because we needed their consent to have the girls attend the workshops. And the girls didn't have confidence. Growing up, engineering was for guys, was for boys. I never heard a girl say, I wanted to go into engineering, either electrical engineering, mechanical, not even talk about computer engineering. So a lot of the girls didn't have confidence in STEM. And the main thing for us was figuring out the direct impact we wanted to create. We didn't just want to teach 2,000 or 20,000 girls how to code. We wanted to have great impact such that they can move forward in their careers as they go. So how did we tackle some of these challenges? One, we changed the strategy from having annual workshops to frequent sessions. And that happened and was inspired by our partnership with the Achievers Book Club, where we train girls at least twice a week. And we saw so much improvement. A lot of them became extremely curious and they wanted to know more about STEM. We try to understand the needs and the capacity of the girls because they come from different homes, different communities, and some of them have less resources. So understanding how they see their future and how they wanted to get there helped us shape the program and the curriculum in general. And we also decided to work with parents and schools for a more collaborative learning and a sustainable income. outcome. Because having the parents on board was very, very important. Because after school, after the workshop, when they go home, they still need the resources to help them continue learning. So partnering and getting on the same page with the parents really helped us go far with the program. And we also had to tweak the curriculum to focus on building a mindset of empowerment. Because once you feel empowered, there's nothing you can't do. And that's our main focus. So what is our impact? For the past 3 to 4 years, Techniques Girls has been running. We've been able to impact and teach about 3,198 girls across Ghana how to code and how to build websites. We went from having no volunteers to 88 volunteers. And we went from having 10 female mentors to 119 mentors. And this shows you that a lot of girls were able to get into the STEM field, in that three-year span. Because finding those 10 girls to mentor for the first workshop wasn't easy. And we've also been able to provide internship opportunities for the young girls in tech companies in Ghana. And one of our dreams and goals is to expand. So we want to scale outside Ghana. And we're able to partner with an organization in Burkina Faso to teach 9 girls how to code so they could in return mentor young girls in Burkina Faso. So we've been able to mentor 49 girls. So what's next for Techniques Girls? We have a dream to have a coding school for girls. And we've been overwhelmed by the number of people that want to be a part of the Techniques Girls initiative, that want to be part of the program. And so we want to start a school where we can teach girls primarily how to code and across West Africa, so not just Ghana. And we also want to involve more girls in a mentorship program. So one of the main issues, aside girls not really feeling confident to go into the STEM fields in Ghana, is the fact that a lot of them want to get out of the STEM field. Like in my class, 80% left STEM right after college. And that was disheartening because a lot of them had so much potential. They could have done so many amazing things in inspiring other girls. And so our dream is to keep girls who get into STEM in STEM. And so with the Techniques Girls Mentor Clubs, we'll be able to get mentors and girls studying computer science in college to mentor young girls, and in return, they mentor other girls in their communities. Since Techniques Girls, there have been several other initiatives in Ghana, teaching young girls how to code. And it's really, really inspiring to see that. I mean, in a way, a lot of people are thinking about how to build the next generation of leaders. And the fact that a lot of them are doing it using technology means that we're not only empowering them to understand technology and to build great products for development, but then we're enabling them to afford more opportunities and to become economically stable. And so I'd like to end by thanking WITI for the opportunity to share my story. And as a Mandela Washington Fellow and an African leader, USAID and IREX has been very supportive in my speaking engagement. So thank you all.
Thank you, Rasheeda. Well, we have just over 5 minutes left for questions and comments. Yeah.
After I met President Obama, they're cool.
That would help, I would imagine.
Yeah.
Yeah. Other comments, questions? Internet of Things, Magic Pocket? Yeah,
Hi, I have a question.
there's a
Have you
mic.
thought about or interacted with anybody in any other countries in your region about your successes, and do you connect? I'm just curious about your connection and the possibility and opportunity to expand what you're doing.
So we're definitely looking for partnerships and ways of scaling outside Ghana and outside West Africa. So far, we've only partnered with an organization in Burkina Faso. But then we've also had companies like Google and institutions like Dartmouth come down to Ghana to help us shape our curriculum and to teach the kids human-centered design and so many things that are in line with what we want to do. So we're definitely looking for partnerships outside Ghana and Africa. Yeah.
Yeah.
Hi there. So fantastic talks by each of you. I really did learn something, so I really appreciate that. I wanted to ask Akhil, when you're working on the Magic Pocket, when you look at all the different tools and languages, so since there wasn't an open source out there and there wasn't those tools, how did you go evaluating, like what languages did you end up deciding to use? I mean, was it the Pythons and MongoDBs and things like that, or?
So most of the code is actually written in a language called Go. This is a language which Google started. The design choice for the language was we knew that we had to have a language where multi-concurrency is almost inbuilt. That made Python a difficult choice for us. Performance was going to be a big deal for us just because we knew that large systems also had to be very performant. And the third criteria was just to make sure that we are able to work with the low-level hardware, which again, Go does provide.
We're out of time, I guess. We're at 0. Thank you very much for attending this
Thank
session.
you.
Thank you to our speakers.